Okay, in regard to making our own energy, there's different ways to do it if you didn't have solar panels, which I think is probably the best option, but this is another one people might try as a generator. Now, this is not, it looks like a car generator, and the casing is, but it's actually a custom wound generator with permanent magnets inside and special windings to put out voltage at low RPMs. I actually ordered this for a windmill, a low-speed windmill, but I decided to put this hand crank on it. I made this up with different lengths for different torques and speeds to allow it to be used as a hand crank. You can see the pulsing in it from the magnets. And it does work well, but it's really inefficient use of energy. Your arm's just not made to run this for very long. It does work very well to charge up supercapacitors though. Charges them up nicely, and then those can be used to run LEDs, and I'll show you that. Okay, I hooked up the hand crank generator and ran over some temporary wires to a bank of supercapacitors, and these are at 2.7 each, which would be 5.4 max, and they run this. This is a converter. It converts from 1 volt up to 5 volts, anywhere from 1 to 5 volts up to 5 volts, so then you can plug in your lights and such. So we're going to plug that in and show you what it can do. Okay, so as you can see here, I hooked up the supercapacitors and the voltmeter, and right now they're at 0.3 volts. And as you see this get up to a volt or so, there'll be a red light come on that up converter, and I plugged in a little LED light. So we'll start turning this, and you can definitely feel it's harder when it's plugged into the supercapacitors because it's drawing about, well, it's almost just like a straight short, so it draws 10 amps easily. So here at 0.6 volts, and this does seem crazy, but this is drawing a lot of power to charge these capacitors. And then the red light came on, and already the light's starting to shine at 0.8 volts because it's converting that up to 5. So with this, I'm still cranking it. You can go faster or you can go slower. This is probably putting out around 6 or 7 volts right now, and as it charges these, we'll see that. But so we're at a volt now. Let me go up to 1.5, and we'll see how long the light will run at that. Again, almost all this energy is going into those capacitors now, though, which is much better than trying to go into a battery. Of course, if you were powering this directly, you could turn it and it would light up, but as soon as you stop turning it, it's going to stop lighting up. So, okay, there's 1.5, and let's stop. It's going to drop down some right away, but. So there, I'm not cranking. Voltage is at 1.4. Light is lighting up nicely. Let's see how long this lasts. This could last quite a while. I had a large light plugged in, and you could watch it drop down, but this one's staying steady. This is quite a little bright light. It would easily light up your room at night, enough to see by. I was cranking, what, a minute or so, and I'm going to pause this and come back. Okay, I guess it doesn't really give you an idea how long it is, but I paused it for just a minute or so to try out that other light. But it's getting down to 1.2. The light's not as bright, but the circuit board still has the light on it there. I think it'll run down to 1 volt. I'm guessing though, a good 5 minutes, a minute or so cranking and 5 minutes with these supercapacitors. Again, the point is you can use this energy. You could have somebody cranking it, but really to get a lot of energy you want to hook it up to your legs somehow, to crank a generator with your legs, and we'll be showing you that in an upcoming video. It's much quicker, more efficient. For instance, I put 6 of these, actually just with these 2 capacitors I could charge them up with a leg generator, a leg crank, and it took me about 10-15 seconds of putting out 15 amps or so into these capacitors, charge them up to 5 volts very quickly, and then it will run the light for much longer, obviously, with 5 volts in those instead of 1.5. But you can see the supercapacitors, they work well. They hold their charge even under a load. They charge up very efficiently. It's really the way to go for home power generation. So this is sort of, it's useful. You could charge your phone with it, I suppose, plug it into the USB. I think I'll move that handle in a little further even so I can get a little more speed out of it. There is a bit of force on there to turn that though. You can definitely feel it. Alright, stay tuned for the next videos. Thanks for watching. Okay, this is still running from that last video. It's down to 1.1 volts. It's still running the light though from that cranking by hand. This is another setup I had though to show you the leg power. This is a 24 volt scooter motor, and I put this sprocket on it. And chain drive is much more efficient than belt drive. Don't try direct drive either. You can see I tried it here and it uses up a lot of energy and heat. You can see as it melted the plastic off the hub. It's just not very efficient at all. You could only get maybe 100 watts of power before this would always start to slip. So I put the sprocket on here though with a chain. It's much more efficient, and you can get over 200 watts peak power out of it. It is on a big flywheel. This is an exercise bike I got from Goodwill. So with this, I put a diode in it, which is very important because otherwise the power will go back and turn the generator into a motor. But I hooked up several options for it. This is a current meter, so we'll see that when we charge up the supercapacitors. This is a 3 amp to a micro USB. I use that to charge up battery banks, so you can run this easily and it'll put out 3 amps to charge that quickly. Also have on here, this is all just preliminary wiring for experimental use, but there's a 12 volt outlet. There's also a USB adapter there. These are very useful because they allow a higher voltage to stabilize that USB output, and there's a lot of USB devices such as lights and such. This is another one here. It's a USB plug, but it goes to multiple adapters for charging different phones, etc. So as this gets down, it's still 1 volt. I'm going to short these out some to try to drain this down to 0 and show you how quick we can charge it up to 5 volts with the leg generator. Okay, we're down to 0.2 volts. I shorted out the leads, and you can see that little converter light is still on at 0.2 volts. Amazing. But the lights are off, so now we're just going to charge this up in real time so we can see. Don't mind the mess. Hopefully you can see the current meter down there. We put out over 10 amps. And we'll watch the voltmeter too. So it's at 2.5 volts already, 3 volts. 4 volts. 5 volts. Slow down and not overcharge it. The generator's putting out 7 volts right now at this low speed. So there in a minute or so, however long that took. It is some cranking, but the flywheel really helps stabilize that energy. And it's kind of stabilizing out at 4.8 volts. So now these have a lot more energy. All that energy is stored in these supercapacitors. Running a light or whatever else you want to plug in. You can plug in your phone charger. Anyway, much quicker to get up to voltage. You can see I was putting out over 10 amps there the whole time in the beginning. So if you have any questions about this, this is all preliminary. I'd like to shorten the chain and move this closer, make it more compact, but we'll do that later. Thanks for watching.